So the first thing, once again, is to rewrite the equations. To write the equations out, that's the first thing. And the equations are these. All right, so we don't need to name them this time around because the Cramer's rule has to do with the use of it's related to, it has to do with the use of a matrix in solving a pair of equations. So what we'll need is not about which one is equation 1 and which one is equation 2. That does not matter here. But what is the Cramer rule or Cramer's rule all about? So the first thing we are going to do is to have matrices drawn. So the first thing I'm going to do is to draw a matrix symbol or box. Now, in the first equation, the coefficient of x is 7 and the coefficient of y is -4. In the second equation, the coefficient of x is 2 while the coefficient of y is +1. So the first thing to do is to extract the coefficients. Extract the coefficients. That is the first thing to do. All right? Yes. Okay. What does this mean? It means this. The coefficient of x here is 7. So we write 7 here. The coefficient of x in the second equation is 2. We write 2 down here. The coefficient of y in the first equation is -4. We write -4 here. And the coefficient of y in the second equation is +1. So we write 1 here. So these are the coefficients. What we've just done is that we've extracted the coefficients. So the next thing to do is to write out the constants in the other matrix here. So the first constant up there is 23 and below that is 13. Yes. So this column is for x while this column is for y. And this matrix is for the constants. Now we could just label the columns. We could label this x, this y, and let's call this p. So I want to redraw the matrix labeling the columns. This matrix is called a 2x2 matrix, but of course that is not very necessary now. Knowing the name or what it stands for does not really matter in this lesson, okay? But it's a 2x2 matrix, while this is a 2x1 matrix. Let's forget the name for now. That is not important in this particular lesson. So I want to redraw these matrices, okay? And I want to give room for labeling the columns. So the first matrix, I'm redrawing exactly the same thing I did the first time. I'm just redrawing to give room for labeling. Okay. So here, 7 and 2 represents the column for x. -4 and 1 is the column for y. Then 23 and 13 are the constants. So let's use P to represent the constants. So we can conveniently call this the XY matrix. Let's just call it the XY matrix. Okay. So the next thing to do is this. We are going to find the determinants of the X, Y matrix. That is this matrix. What is the determinant of this matrix? What do we mean by determinant? I'm going to show you. So in finding determinant of a matrix, this is what we do. We draw two vertical lines which represent the boundary of the elements inside the matrix. And the elements here is written, the elements in the matrix are written down accordingly. And then the next thing we want to do is we want to multiply the elements in the leading diagonal or the principal diagonal. The diagonal from the left to the right, top to bottom like this, is the principal diagonal, while the other diagonal here is known as you can just say the other diagonal. Okay, so the product of the elements in the principal diagonal minus the product of the elements in the other diagonal. But before then, let's look at a sign that we can use to represent determinants. So we can use this sign, for instance, to represent determinants. So the determinant of this matrix goes this way. Determinant equals 7 times 1. Should I put that? Okay, let me do it this way. 7 times 1 minus 2 times minus 4. So what we're just doing here is simple. The elements in the leading diagonal are 7 and 1. We find the products, which is 7 times 1. The elements in the other diagonal are 2 and minus 4. We find the products. Then we find the difference between them. Now, determinant equals 7 times 1, 7, minus 2 times minus 4 is minus 8. So we can say minus 2 times minus 4, minus 8. Okay, that gives us determinant equals 7 minus times minus is plus, and we have our 8. So that means the general determinant is 15. So 15 is the determinant of the XY matrix. So what is the next thing to do? All right, let's go to the next thing to do. Having found the determinant of the general matrix or the XY matrix, the next thing is to begin to solve for X and Y in turns. Let's solve for X and Y in turns. Okay. All right, so let's start. Now, let's look at what we have here in the coefficients. We have 7, 2 representing X because the two coefficients of X in both equations are 7 and 2. And we have minus 4 and 1 representing Y because the two coefficients in both equations, of Y are minus 4 and 1. And the constants remain 23 and 13. So X column is 7, 2, Y column is minus 4, 1, and the constant represented with a P here is 23 and 13. Any letter could represent the constants. Anyway, now we are going to solve for X. Is the next thing we are doing. Solve for X. So now to solve for X, we are going to draw our matrix again, or draw the symbol for the matrix, right? This is the X column, and this is the Y column. Yes, X column and Y column. Now, if we are solving for X, we are not going to use the coefficients of X. So the column of X will be removed. Okay, the elements in the X column will be removed and they will be replaced by the constants. The elements in X will be removed and they will be replaced by the constant. So instead of 7 and 2 under the X column, we're going to have 23 and 13. But in the Y column, the elements remain -4 and 1 because we are not dealing with Y at the moment. We are dealing with X. So this is what we are going to have next. We're going to have 23, 13, -4, and 1, meaning that we remove the elements in column X and replace them by the elements in the constant matrix. So let's see how that goes. So 23 and 13, remember, are the elements in the constant matrix. So while elements in Y, in the Y column, remain -4 and 1. -4 and 1. So this is what we are working with. Now the next thing is to find the determinant of X, or find X variant. You can call it X variant or you call it the determinant of X. Now to solve determinant once again, it remains the same way. Draw a vertical line and another vertical line representing the boundary of the elements in the matrix. So you have your 23 up here, 13 down here in this column, and in the second column you have -4 and 1. So we can represent the determinant of X or X variant by this sign or symbol. Now, X variance or determinant of X will now be the product of the leading diagonal, that is 23 times 1 minus the product of the other diagonal, which is 13 times -4. All right, so X variant is equal to 23 times 1 is 23, then minus 13 times -4 is -52. Now, X variant is equal to 23 minus times minus is plus 52. Okay, so X variant will give us what? Simple. X variant should be giving us this now. So let's continue. X variant or X determinant is equal to 75. Yes, we found our X determinant or X variant. The next thing is now to find X itself. Let's look at the working formula for X. X will be equal to changing X over the general change, or X determinant over the general determinant. Let's see the workability of this formula. Now, over X. Now, if I write 2X over 2, right? 2 cancels 2 and my answer will be X. That means X can be equal to 2X over 2. So the same way I have it here, this sign can cancel this sign. I have my X. So that means X is equal to changing X over general change. Of course, when the D's cancel each other, we have just X. So X will be equal to X. So this formula is workable. Now we can go ahead and solve. Okay, going ahead and solve, X will be equal to, changing X is 75 over, who remembers what the general change is? Okay, it is 15. So the general determinant is 15. Therefore, X will be equal to 5. That's 75 over 15. X is equal to 5. Okay, the next thing is to look for Y. But I want to go over these how we solve for x again. Okay, it's all here. So what did we do? We replace the values, the elements under the column of x with the elements in the constant matrix and retain the elements in y. Then we find the determinants of this matrix. Then we get an answer. That's just simply what we have to do. Then we say our x will be equal to x determinant over the general determinant. That gives us 75 over 15, and that's fine. Now we're going to look for y using the same method. So the next thing to do is to solve for y using the same method. The same method we used in solving for x is going to be used in solving for y. So what's the first thing again? The first thing is to draw the matrix symbol. And now let's quickly go back up because we're dealing with y. We're not replacing x. We are replacing y, but retaining x. That's 7, 2. Then in the y column, we remove the elements and replace them by 23 and 13. So we're going to have 7, 2, 23, and 13. Now, what is the next thing? The next thing, of course, just like we did for x, is to find the y variant. Okay, find the determinants of y. So we can use this symbol as well. Y determinant equals, we draw the two lines, 7, 2, 23, 13. So that means we are looking for the determinant of this matrix. That's the determinant of y is equal to 7 times 13. That's the product of the elements in the leading diagonal minus the product of the elements in the other one. So dy is equal to 7 times 13 should give us 91. Minus 2 times 23 is 46. So y determinant should be equal to 45. So who can tell me what we have to do next? What do we have to do next? Okay. What we have to do next is the same thing we did when we were solving for x. Look at it. It's still here on the screen. So we are going to find y now by using this working formula. Y will be equal to change in y over the general change. So y will be equal to the change in y, or y determinant is 45 over the general is 15. We don't need to go back up there. So y will be equal to 5. Now we can conveniently say, therefore, let me put it here. Therefore, x is equal to, 45 over 15 is 3. Okay, that's not a problem at all. So that's 3. So x is equal to 5, while y is equal to 3. Comparing this answer with the ones we had when we used the substitution and the elimination method are the same. Therefore, all workings are correct and all the answers are also correct. So this is how we solve pairs of equations simultaneously using the substitution method, the elimination method, and the Cramer's rule. I hope you enjoyed this lesson. Thank you so much for joining, and I hope to see you in another video. My name is Mr. Shine. Bye for now. Bye-bye.